Hello, today we're going to see the topic of algebra. This is from 5 topic, and in this topic actually students is going to be taught the following subtopics. So first of all, you're going to see exponents, that is laws of indices. So here we're going to see exponents and radicals sometime, and also graph of exponential functions, laws of logarithms, equations involving logarithm and indices. You'll be in position also to convert logarithm from one base to another, graph of logarithmic function, definition of finite and infinite series, expressing series in sigma notation. Then you're going to derive formulas for sum of first n square, formula for sum of first n cubes, application of sum of first n squares, application of sum of first n cubes, mathematical inductions, rules of polynomial functions, relations of roots and coefficients in cubic functions, form equation from the roots, remainder theorems, solving quadratic inequalities, solving inequalities involving rational functions, solve absolute value inequalities, and also you are going to go to matrix, whereby you are going to determine determinant of 3 times 3 matrix C. You are going to use Cramer's rule to solve 3 linear equations. Later you are going to see inverse of matrix. You're going to solve linear equations using inverse of matrix. And later on, you're going to see Pascal's triangle. And also, you're going to expand the binomials using Pascal's triangle. You're going to expand also binomials using combinations. And the last part will be partial fractions. So these are the subtopic of this topic, algebra. And if students is going to be in position to understand all these parts, it means now there is no problem with this topic. So this is introduction part, and as part of introduction, I'm going to introduce to you laws of indices, and that is exponents, and this is part of logarithms and exponents. So let us start by saying that we are going to look on logarithms and exponents. So under logarithms and exponents, let us start with exponents. So in exponents, actually you have to remember exponential rules. So we say exponential rules, which you were taught actually in O-level. So the first one, you say, you know that any number to power 0 equals to 1. The second one, you know that if you have a power x times a power y, this is equal to a power xc plus y. The third one, if you have actually a, before I go there, I'm going to say if you have again a power x over a power y, you know that this is a power x minus y, of course. Another one is when you have a power x power y again, we know that this is a power x times y. And the fourth one, if you have nth root of a, you know that this is a power 1 over n. So we have actually a transformation between radicals and exponents, and that's how we are representing radicals in form of exponents. And also the next rule, and this is going to be used actually in solving exponents. If we are going to solve exponents, we are going to use two important rules. We are going to say that if a power f of x equals to a power g of x, we can say that then f of x equals to g of x. The next one and the last one for this part actually is, if you are having f of x power n equals to g of x power n, then understand that actually the base, which is f of x, is going to be compared with g of x. So we are going to use these rules actually in solving questions related to exponents. Let us see example. Call it example number 1. Solve for x. So for x, x being all real numbers, given that actually 9 power x equals to 27 power 3 over 4. So we say solution. We know that 9 power x can be expressed actually 3 square power x equals to 3 power 3 over 4. So 3 power 2x equals to 3 power 9 over 4. Since the bases are the same, it means we are going to compare exponents. I'm going to say that 2x equals to 9 over 4. So x equals to 9 over 8. So the value of x is 9 over 8, dear friend. Now we go to second example. In example 2, so we are supposed to solve for x, given that x power 2 over 3 minus 5 over minus 5 x power 1 over 3 plus 6 equals to 6. So here is solution. As you can see from the equation, actually the equation can be rewritten as x power 1 over 3 square minus 5 x power 1 over 3 plus 6 equals to 0. And actually this is quadratic equation with variable being x power 1 over 3. So for simplicity, we can let, for example, let a be x power 1 over 3. And now we can see that actually the equation now can be deduced to a square minus 5a plus 6c equals to 0. So now this is quadratic equation. We can solve it. Actually, it is factorizable. So we can solve the equation by splitting the middle term. We can split the middle term, and the factors are -2 and -3. So here will be a squared minus 2a minus 3a plus 6 equals to 0. You have a minus 2 minus 3, a minus 2 equals to 0. As we can see, negative a minus 2 is common, so we can take it out of the bracket. In the bracket remain a minus 3 equals to 0. So the result is a minus 2 equals to 0, or a minus 3 equals to 0. So a equals to 0 or a equals to 3. So if that is the case, we remember that from beginning we say that a equals to x power 1 over 3, and we are looking for x, so x actually is a power 3, because we can actually take third power in both sides. We can introduce cube both sides, so x will be equal to a power 3. So when a equals to 2, it means x is going to be 2 power 3 or 3 power 3. So x equals to 8 or 27. Therefore, the value of x is 8 or 27. So that is second example, and we come to the end of this session. In the coming section, we are going to see logarithms. We are going to see also graph of exponential functions, graph of logarithmic functions, as we continue covering the important parts of this topic. In case you have any question, you can ask your question in the comment section. Don't forget to share these materials to your friends, so that we benefit, our cycle benefit from this. Thank you very much. All the best.